Hello, hi, good morning my dear students, welcome to the chemistry class. So in the last week we have begun problems on states of matter, and today will be the last class. So we thought to finish in the last week only, but due to we should not feel the very speed, for that reason I am making the two videos. So let's start the next problem, that is problem number 5.3. Just go through the given data. So at 25 degrees Celsius and 760 mm of Hg. Look here. So pressure we are having actually some SI units. So I say you bar is one of the SI unit, and I say you atmosphere is one of the SI, and I told you TORR top is one of the units. And actually SI unit is only the bar. But sometimes they are going to use different units for the pressure. And again here mmHg means millimeter of Hg. Generally we are calling that as mm of Hg. So means based on the mercury presence, how many millimeter of mercury the length is. So it is based on mmHg. It is one of the unit for used for the pressure. So these are the units for pressure: bar, atmosphere, or mm of Hg. These are the SI units. So here also at 25 degree and 760 mm of Hg pressure, the gas is going to occupy 600 milliliter of volume. So it means that at a temperature T1 25, pressure is T1 760, volume they have given at 600 milliliter. So here I have converted the temperature 25 degrees Celsius into the Kelvin by adding 273. So 273 by adding plus 25, we are going to get 298 Kelvin. Again the problem is continued. Here the condition is what will be its pressure, means pressure they are asking. That's why I have written P2. If it is these terms are P1, 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 and like next coming pressure volume temperature will be 2. So what will be the pressure, means they have asked us to calculate the pressure. It means that what will be the pressure when the temperature is 10 degrees Celsius and volume is 640 milliliter. So here we have to calculate the P2 by using the T2, V2 and V1, V1, V1. So here also I need to convert 10 degrees Celsius in the form of Kelvin by adding 270. That becomes 283 Kelvin. So I hope I said you. First, you have to write the given data properly. Only after writing the given data, you are going to get 1 marks. Means not only pure 1 marks, but the marks are distributing in this way. First, you have to write the given data. Next one, you have to write the formula. Which formula is suitable? First, write the formula. Don't go directly without writing the formula. You are not supposed to substitute the data. First, you have to write the formula. Means given data. Soon after equation, means you have to write the formula. After writing the formula, you have to substitute. You have to substitute the values, and after substituting, you can write directly the answers. But means first you have to write the formula and substitute that one, and later you calculate and write the formula. Means answer. Those answers should be with the units. Temperature means you have to write the Kelvin, and volume means you have to write the units whichever they are used, like liter, milliliter, or something. So answer should not be with the units. If it is not in a unit, means you are going to lose the marks. Okay, this is what you have to continue here. So look here. So here we are having totally 6 variables. How means P1, P1, V1. This is 3 variable. P2, P2, V2. These are the 3 variables. So here among these 6 variables, they have given 5, and they are telling us to calculate the one, that is P2 you have to calculate. So here totally 6 variable. It means this is according to the formula that is called as by using combined gas law. Combined gas equation. By using the combined gas equation, means this formula is called as combined gas equation. So P1 V1 divided by P1 is equal to P2 V2 divided by P2. So look here we are having all the values except P2. So where the P2 is there? P2 is here. So here I have to rearrange the equation P2. So how to rearrange the equation P2 means, look here, P2 I1. You just put P2 here as it is. You just send one by one from right to the left side. So first we will send the P2. P2 according to the P2 is at the denominator. So next side it will move to the numerator. Means P2 will come this side. Therefore P1 initially as it is. P2 coming to this side. P2. V1 will come to the, it is into, when V2 comes here it will divide, means V2 comes in the denominator divided by T1 as it is, and I am writing the V2 here. So this is about the P2. So P2 is nothing but P2 is equal to P1 V1 T2 divided by T1 into V2. So here we are going to substitute the value P2. So P1 is nothing but what here? P1 is equal to 760. This is into V1 is nothing but 600. T2 is nothing but 283 divided by T1 is nothing but 298 Kelvin. It's not plus, it's also into. Next one is V2. V2 is nothing but 640 milliliters. I have not mentioned the SI units here. No need of mentioning here. Simply write the numerical value and do the calculation, and you are going to get the pressure. V2 is equal to 676.6. But don't write only the numerical value. Here pressure is having the SI unit. It may be a bar, atmosphere, anything, but you have to write the SI unit. Which one they have mentioned here? Can you see here? The pressure of this one is mm of Hg. Therefore, you have to write this one as mm of Hg. So it means that the pressure is going to occupy is 676.6 when we change the temperature and volume by increasing or decreasing. Based on the given data, you should be capable to write the equation, and soon after equation writing, you have to rearrange this one and substitute and get the value, and at the end you have to write the assignments. So I hope you are not feeling that much of difficulty, because these are not to that extent difficulty. So go through this one again, and if you get any confusion means watch this video once again. Okay. The last problem is here. This is 5.4 is 5.4, and for your kind information, this problem is important not for the only first PUC, and this problem will be continuous even in the second PUC. The same problem, the same data, means formula, given data, everything will be same, and it is important for second PUC. Means when you move to the second PUC, you are going to solve the same kind of the problems. Okay. For that reason, it is important. Look here, the 5.4, they have given neon and dioxygen. These are gas are mixed. These are the gas are mixed. Means which one? Neon and oxygen. Dioxygen is nothing but it is having oxygen 2 molecules, that is O2. So here it contains 70.6 gram of dioxygen, means O2. It is having 70.6 gram of oxygen, and neon containing 167.5 gram. So dioxygen and neon, these are the mixture. They have mixed, and after the mixing, the mixture is having the pressure. In the problem they have given, the mixture is having, means the total pressure of the mixture together it is. The total pressure is 25 bar, means they have used the pressure in terms of bar. So total pressure is 25 bar. So then they are asking us to calculate the partial pressure of individual gases. Here individual gases are nothing but, here we are having the two gases, that is oxygen and neon. So calculate the partial pressure of the oxygen, means pressure of O2, and pressure of neon. You have to calculate these pressures. So keep in your mind, they have given the total pressure. So 25 bar is the total pressure. Among these 25, something is about, some of the pressure is on oxygen and some of the pressure by the neon. together it is having the 25. So now how we have to calculate the partial pressure of oxygen and neon by this given data. So let's start this one. Here they are asking you to calculate the partial pressure. So partial pressure is nothing but, look here. So in the last week we have derived some of the equations. I think the behavior of the gases. Before that one we have derived some problems. That is equation P1 is equal to x1 into Pt. P1 is equal to x1 into Pt means partial pressure of first gas number 1 is equal to x1. x1 means mole fraction of component 1. Pt is nothing but total pressure. Similarly we can write, instead of 1 we can write 2. P1 we have written as P2, x1 we have written as h2. Pt is same as it is, means partial pressure of total gaseous compound, means mixture of the gases Pt. So look here, P1 P2 it is. P1 is nothing but partial pressure of first gas, means gas number 1 or first gas, and that gas is mole fraction it is, and this is total pressure. Whereas P2 is nothing but partial pressure of second gas, x2 is nothing but mole fraction of second gas, Pt is the total pressure. This is what you have to calculate here. So they ask you to calculate the partial pressure of oxygen, partial pressure of the neon. Means 1 is nothing but oxygen, 2 is nothing but neon. Means you have to calculate this one by using this expression x1 into Pt. But Pt they have given, means total pressure they have given as a 25 bar. But x they have not mentioned. X is nothing but mole fraction. How to calculate the mole fraction? Look here, by only deriving the problem, this is not important. So whenever we have given the problem, means you have to chart out that one. How to solve by the given data? What formula you have to write the first? You have to go through in this way only. So this is the main important here. So which one how I am solving, that is not the matter. How I think to solve, that is the main important here. That's why please concentrate here, and somewhere you write this apart from the answer. I place in the margin or make it as a short notes. So to calculate this equation, x we need to calculate. Whereas x is nothing but what? Mole fraction. So mole fraction can be calculated by the formula Na divided by Na plus Nb. Here A, to calculate the mole fraction of component A, we have to calculate Na is nothing but what? This is Xa means mole fraction of component A, that is equal to Na upon Na plus Nb, where Na is nothing but number of moles of component A. Component A means here A is nothing but first component, B is nothing but second. Means how many number of moles of component A is there, that you have to write that A mole fraction you are calculating. Means Xa is equal to Na divided by Na plus Nb. How to calculate this N? N is nothing but number of moles. You have to remember X is nothing but mole fraction it is. Mole fraction. You have to remember the meaning of this word. X is nothing but mole fraction. N is nothing but number of moles. Can you see here it is slightly variable. Mole fraction is nothing but X. Number of moles is nothing but N. So here N how to calculate means number of moles can be calculated by the formula W divided by M. But in your textbook and even in the notes it's not mentioned. Why? Because it's a common term. Means in the previous first chapter we have derived this equation N number of moles. It was there in the first chapter also. So here N is equal to W divided by M. So N means number of moles. W is nothing but given mass. M is nothing but molar mass. M is nothing but molar mass. So W means given mass. They have given the oxygen 17.6 gram. They have given. So 167.5 gram of neon. They have given. That given mass is nothing but W. But here M we have to calculate ourselves. How means they have mentioned that dioxygen. One oxygen is having the atomic mass is 16. One oxygen is atomic mass is 16. Dioxygen is nothing but 2 oxygens. So totally 16 plus 16, 32. 32 is nothing but molar mass. Are you getting? Neon. They have taken the neon as 167.5 gram of neon. But neon is only one. What is the atomic mass of one neon? That is known as molar mass. Are you getting? Actually, molar mass is nothing but it is the mass of the compound of 1 mole. 1 mole of compound. mass of 1 mole of compound is called as m, molar mass. So here my main intention is to solve this one. We are not supposed to write this equation first. We have to go from reverse, means first you have to calculate the n. To calculate what you need, m you need, means you have to first write down the molar mass of the compound, and next calculate the n by using n A and n B, means both oxygen and neon, and you have to calculate the x, xA and xP you have to calculate, means one fraction of oxygen and neon. Then you have to move for the partial pressure. Here P is equal to x, Pt. X is nothing but what? Mole fraction. P means P1, P2. These are the partial pressure. That's what you have to calculate here. So let's start this one. So based on this given data, first we have to calculate the molar mass. So we know that the molar mass of the oxygen. So molar mass of oxygen is equal to, means O2 is equal to 16 plus 60, that is 32 gram, and molar mass of neon. So actually neon is having the atomic number 10, therefore atomic mass is 20 is 20. Probably in the annual exam they will give you the molar mass. If they are not given, means you have to remember that one. So molar mass of oxygen, molar mass of neon. So now what you have to calculate? First you have to calculate the n value. So n is nothing but number of moles. Number of moles is equal to W divided by m. So let's start the number of moles of oxygen. O2 is equal to how much oxygen they have taken? 70.6 gram divided by molar mass of oxygen is 32. You divide and get the answer, and n is nothing but number of moles of neon, W divided by m. W means how many neon they have taken? 167.5 gram divided by molar mass of neon is 20. You just divide and get the answers here also. Next we will start the XA. Here X is nothing but mole fraction. So yes, first we will calculate the mole fraction of oxygen, dioxygen, that is Na upon Nb. N mole fraction of, if we are calculating the mole fraction of oxygen, means we have to write the number of moles of oxygen first and divided by number of moles of oxygen plus number of moles of neon. Means we can write Na upon Na plus Nb also, no problem. Okay, look here. So to calculate the number of, means mole fraction of oxygen, we have to write the number of moles of that oxygen only first. Means oxygen calculating means number of oxygens divided by number of oxygen plus number of neons we have to write. So here number of oxygens means number of moles of oxygen is 2.21 divided by again 2.21 plus number of moles of neon is 8.375. So you just divide first one, means you just add this one and divided by the sum. You are going to get some value. And the next one I would like to tell you mole fraction of neon. So no doubt here also mole fraction of neon you can calculate by the same formula, means number of moles of neon divided by number of moles of oxygen plus number of moles of neons. So total number of moles of air, and which one you are calculating mole fraction, you have to write that one in the numerator. This is the one method, the common method. So here I would like to tell you one more method here. What means, here I have taken the mixture of gases. Can you say they have given the two oxygens? What it means, one oxygen, one is nitrogen. Means a mixture of gases. Here the gases mixed is only two gases are mixed. Means number of gases mixed is 2. One gas is having the mole fraction, that is I would like to write as a x1. Another one is having the mole fraction as x2, and together the mole fraction of first gas and mole fraction of second gas, together it is always having the value 1. We are never bothered about which gas is present. The gas may be anything, but together the sum of those gaseous mole fraction of, not pressure I am talking about the mole fraction. Mole fraction means we have calculated here. Na means XA is equal to XA. Suppose XA happened. Suppose if it is XA there, Na upon Na plus Nb, and XA plus XB means if two compounds are there, XA plus XB, and together its value is always equal to unity. Unity matlab 1. So XA plus and XB means if it is having 2 here, that's why x1 plus x2 is equal to 2. If it is having 4, the sum of all the mole fraction of 4 gases, it is always equal to 1 only. Means mixture of the gases, those mole fraction of that mixture is always remains 1. So why I am telling this one means here we have calculated first mole fraction, and next mole fraction no need of calculating by this way. So I can calculate it by that one. Means we know that mole fraction of neon plus mole fraction of oxygen together it is always equal to 1. So to calculate the mole fraction of neon, we are going to send the mole fraction of oxygen to the right side. Therefore, what remains as it is plus x. If it push to the other side, it will become minus x2. Means mole fraction of oxygen 1 minus x1. So just you put these values and calculate this one. Look here. Now we have calculated the from the molar mass, we have calculated the number of moles of oxygen and number of moles of neon. By this Na and Nb, we have calculated the mole fraction of oxygen and mole fraction of neon. So mole fraction of oxygen is 0.21. Therefore 0.21 means 1 minus x0. 1 minus 0.21, we are going to get the mole fraction of neon as 0.76. So mole fraction is not having any assignment, that's why I have written only the number 0.21, and another one is 0.79. This is oxygen, dioxygen, this is neon. So look here, now we have calculated the N, means N I have calculated number of moles. By this N I have calculated the mole fraction of dioxygen and neon. Now by using this one I have to calculate the partial pressures. So first I would like to calculate the partial pressure of oxygen, means O2, that is partial pressure means just like this one. P1 is equal to x1 into P2. So P1 matlab I have taken as oxygen. So partial pressure of oxygen I have to calculate, that is equal to x0 means mole fraction of dioxygen into total pressure is into total pressure. So mole fraction of oxygen, how much it is? Look here. Mole fraction of oxygen 0.21 into total pressure, how much it is? Total pressure they have given 25 bar. So total pressure is 25 bar. So here can you see on what basis we are solving? Means we are solving the problems by the given data as we have observed here. Means by the mole fraction given and total pressure we have derived this expression, and the final one we have asked this partial pressure of oxygen, partial pressure of neon. For that reason the partial pressure of oxygen we have calculating by mole fraction of oxygen into total pressure. Similarly the partial pressure of the neon we can calculate by mole fraction of neon into total pressure. So mole fraction of neon is 0.76, it is 0.79 into PT, means total partial pressure is 25 bar. So by multiplying these two we are going to get the answer as the partial pressure of oxygen is 5.25. In the given data they have given the total pressure as bar. That's why I am writing here also the partial pressure of oxygen is 5.25 bar. Which one they have given the partial pressure? That one we have to write. Therefore partial pressure of the neon is, can you see here? One is 5.25 and another one what it should be, because the total pressure should be 25. So in 25, 5.25 is oxygen. Remaining pressure should be the neon only. Therefore 19.75 bar it is 19.75. So partial pressure of the neon plus partial pressure of the dioxide together is going to give the total partial pressure, means together it will be the 25. So this is the important derivations, means problem. Go through this equation, and if you are having any doubts, I am sure that you will not get worried, because to solve this kind of difficulty problem I took whole one class. So go through this one. The main important is you are not supposed to forget what is n, what is w, what is x. These terms are more important here. This is the main term here. So even though we are using this for a short time, it will help you in the further classes. Even in the second PUC also, these are the most important concepts. For that reason, so keep in your mind the meaning of the numerical, that is n, w, x, what it means, and formula you have to remember. P1 is equal to x1 into t. So this is the problem. If you want, you can take the screenshot and practice this one. And in the notes, these problems are not in this systematic manner. Go through this one once again and write the assignments, which one I have given in the assignment, and make a notes by observing which one I have sent the notes. So I wish complete and dedicated worth output from you all people. So by that, I hope you will send these notes very soon, at least on by 2 or 3 days. At least in this week, I need a complete notes by you. One day I will give you the time. On that day, you people can send the PDF of your files. Okay, so be ready, keep in your mind. So we will start the new chapter from next video onwards. So if you are having any doubts on this states of matter, feel free, clear your doubts by calling me. Okay, don't hesitate to ask the doubts. Okay, have a nice day. Bye.